In this video, we're going to talk about the law of sines and the law of cosines. The student learning objectives that we're going to cover are determining the number of different oblique triangles that exist given certain side lengths and angle measures, and use the law of sines and the law of cosines to solve oblique triangles. We're going to determine all missing side lengths and angle measures. How to determine how many triangles exist. Things to remember are only one obtuse angle can be formed in a triangle. All angles must sum to 180 degrees. If you are given angle, angle, side, there's a possibility of having two triangles, and side must be between -1 and +1. Let's take a look at this first example. We are given that the measure of angle A is 120 degrees, the measure of side C is 58 feet, and the measure of side A is 57 feet. If the measure of angle A is 120 degrees, it is greater than 90 degrees, meaning that it's an obtuse angle, which means that the longest side should be across from this angle. Side A is 57 feet, it's 1 foot less than side C, so we know that no triangles will be able to be formed since this breaks the only one obtuse angle rule. Next, let's talk about when to use the law of sines. You'll use the law of sines if you're given problems that are angle, angle, side, angle, or side, side, angle. And the formulas that we use with the law of sines are sine of A over A equals sine of B over B equals sine of C over C. We can set up proportions with these formulas to determine different side lengths or angle measures. Let's take a look at this next example. We are given that the measure of angle B is 75 degrees, the measure of side A is 40 centimeters, and the measure of side B is 15 centimeters. First, let's draw a picture and label it with our given measurements. Since we have the measure of angle B and side B, we can set up a proportion to find the measure of angle A. Since sine of A is equal to 2.57, we know that this will not be possible because sine is not between -1 and +1. If you plug the inverse sine of 2.57 into the calculator, you'll get a domain error. With the law of sines, we have to also remember that there's an ambiguous case. Things to remember with this is that it only occurs if you're given angle, angle, side triangles. Let's take a look at this next example. We are given that the measure of angle A is 70 degrees, the measure of side B is 40 feet, and the measure of side A is 39 feet. First, let's set up a triangle and label it with all the given measurements that we have. We can set up the proportion sine of 70 over 39 is equal to sine of B over 40 to determine the measure of angle B. We will get the inverse sine of 0.9637, and if you put that into your calculator, you'll get 74.5 degrees. There is an angle in quadrant 1 and an angle in quadrant 2 that will give you the same value of 0.9637. To find the other angle, you'll take 180 degrees and subtract the first angle you found. Then you can set up two different triangles and solve both of those based on these angle measures. So for the first triangle, we'll use the 74.5 degrees. In order to find the measure of angle C, we can take the 70 degrees that we were given originally, subtract the 74.5, and then we'll get from 180, and we'll get 35.5 for angle C. Then we can set up a proportion. We can do sine of 70 over 39 is equal to sine of 35.5 over C to get the measure of side C to be 24.1. The longest side is across from the longest angle, and the shortest side is across from the shortest angle, so we know that this triangle works out. And then we're going to do the same exact thing with the other angle that we got for B. We'll subtract again 70 and 105.5 from 180 to get the measure of angle C as 4.5 degrees, and then we'll set up the same proportion except we'll have the sine of 4.5 on this side of the proportion. and we'll get the measure of side C to be 3.3. And then everything checks out. The longest angle is across from the longest side, and the shortest angle is across from the shortest side. Next, let's talk about when to use the law of cosines. You'll use the law of cosines if you're given a problem with side angle side or side side side. The formulas that we use with the law of cosines are c squared equals a squared plus b squared minus 2ab cosine c, or c equals the square root of a squared plus b squared minus 2ab cosine c. Remember that we'll only use these formulas when we have side angle side or side side side. Let's take a look at this next example. We are given that the measure of angle B is 95 degrees, the measure of side C is 16, and the measure of side A is 22. We can plug these values into the formula to determine the measure of side B. You can plug all of this into your calculator and you'll get the measure of side B to be 28.3. Then you can plug in all of this into the other formula to determine the measure of angle A. If you plug all of this into your formula, you'll get the inverse cosine of 0.6326, and that will give you 50.8 degrees for the measure of angle A. And you can then take 180 degrees and subtract 50.8 minus and 95 to get 34.2 for the measure of angle C. The other thing that you can do is you can use the law of sines to determine the measure of angle A, and then again you would subtract that to find the measure of angle C. The only reason you can use the law of sines or the law of cosines to determine this angle after you already used this formula is because you have a known obtuse angle. If you didn't have a known obtuse angle, that's the 95 degrees right here, you would not be able to use the law of sines, and you would just be able to use the law of cosines to solve. Next, let's take a look at this example. We're given 3 side measures here. Side A is 13, side B is 19, and side C is 12. So we can plug this into the second formula and we'll get the measure of angle B is 98.8 degrees. Again, we have a known obtuse angle, so we can just use the law of sines to solve for angle A and then subtract both angles that we have to get the final measure of angle C.